Hello dear student, how are you? I hope fine. I am Mustafizur Rahman, lecturer ICT Rajukuttara Model College. Today we will continue our study on chapter 5, that is programming language. We have already discussed about what is programming language and generation of programming language, as well as with translator program, compiler, interpreter, assembler, etc. After today's class, we will learn about steps of program development, basic idea of algorithm, idea of flowchart, some symbols that used to draw flowchart, and we will also able to draw some flowchart for some simple problems. Okay, let's start. There are 6 steps of developing a program, that is problem specification, analysis, design, development, implementation, documentation and maintenance, and it recycles. You see, it recycles. It has no ending. It's a continuous process. In some books you will find there are 5 steps. In some books you may find 7 steps and also 6 steps, but I have choose 6 steps is the standard one. If you write there are 7 steps in program design and development, that will be also okay. Okay, let's start from the first step, that is problem specification. Well, suppose you are assigned to develop a software for Raju College or any other institute, then what you do? You need to discuss with the concerned person of that institute, identify the problem properly, and determine what are the inputs and outputs. Actually, you need to learn about the working procedure, business of the institute that you are going to develop a software or program for them. After that, you are going to in-depth analysis of the small problems. You have already collected information from the company. Now you have divided the problem into some problems, build some mathematical model, and estimate time you need to solve the problem. That means you need to write the program and implement. Maybe this time can be changed, but this is the approximate time you can estimate for solving the problem. After problems analysis, we will start design, how to solve the problem, determine the relation among the some problems, and you find solution through some design tools, program design tools. They are algorithms, pseudocode, flowchart, etc. In today's class, we will learn about this technique of program design tools or analysis tools. In this step, we will also find some input and output design and the relation between input and output also. Now, it is time to start your computer. That means you need to code, you need to write program, maybe in C program or any other programming language. Program written to following, you have already designed algorithm and flowchart or pseudocode. Then you start coding, and you may use C, C++, Java, C#, or any other programming language that used for this purpose. That means you are going to develop a software for the target company, your client company. Now it's time to implementation. You have already created, you have developed the software, then you are going to install it for the concerned company. You may buy some necessary hardware or may ask them to purchase hardware. You install the software and train the user how to use this software for the benefit of the institute. Now, documentation and maintenance. All flowchart, algorithms, pseudocodes, these are considered as documents, and some internal documents that program keep writing, so that they need to change something or modification or maintenance purpose, they need some internal documentation. And maintenance, you need to support them, you need to support the company, institute that you develop software. They may call you frequently for various purpose, and you need to give them after sale service, that means support, system support. Maybe sometimes you need to start from the very beginning, that is the step 1, that means problem analysis. Now this is a broad question. Today we have discussed the steps of program design, and we have completed 6 steps. You need to learn this question and answer with utmost importance, because it's frequently set in creative question. There are some programming models like structure model. There are example of structure model like C, C++, Pascal, QBasic, Algol. They are structure or modular or procedural programming. There are some visual programming like Visual Basic, Visual Java or Visual C++. Object oriented programming, C++, Java, Python, Ruby, PHP, or event driven programming, Visual Basic, C++. Well, you may notice that C++ is under 2 or 3 category. That does not problem. C++ or some programming language have features that may overlap in different structure. So this is not incorrect, this is correct. C++ may fall into object oriented programming, also even in event driven programming. Okay, you need to memorize this slide. From here there are frequently MCQ question is setted. We have already know about program analysis tools or program design tools. They are algorithm, flowchart, pseudocode. Today we will start from algorithm. Algorithm is a method for solving a specific problem step by step. That means if any problem come to you, then you solve the problem step by steps. Suppose you need to go home. So what is the first procedure? You need to make yourself ready. Then you need to go outside of your house. Then you need to call for a transport. This is the steps. Okay, so any problem solved by step, that is called algorithm. And there are some condition or features of algorithm. Each algorithm must have some input and output. It must be completed within finite number of steps, and each step should be specified and clear. Okay, must be completed within finite number of steps. That means algorithm should not be like that. I am riding on a transport and started journey, not like that, because in the previous statement I have mentioned such a way that it has no ending. I have started, but where to finish? So algorithm must be a finite number of steps. You need to mention where to end, what is the ending point. Here we see example of an algorithm, and this algorithm will calculate the sum of two numbers. In first step, start, we are going to start to solve the problem, step 1. Step 2, we need to take A and B as input. That means two numbers. I have assumed that A and B are two numbers. Okay, in third step I am going to add this two number and calculate the sum, and in fourth number I am showing the result, the sum as result, and then stop. And there are various ways to write the same algorithm. So it can be varied, steps can be varied from each person to other person. Here is flowchart. Actually flowchart and algorithm is very similar. Flowchart is the pictorial form, visual form of algorithm. Flowchart is a method for solving a problem by drawing some picture or symbols. So drawing a picture that is easier to understand for all people, where algorithm is descriptive type and flowchart is graphical based. Okay, there are specific symbols. You cannot use any symbol whatever you want. There are some specific rules and regulation for drawing algorithm. We will learn about the rules and regulation in our next class, but today we will learn the symbols. Flowchart is easy to understand for all because of its pictures, visualization, and this is the communication way between user and programmer, because user can also understand flowchart, because user may not able to understand the difficult coding, C programming, but flowchart and algorithm, these are used to use as an interface between user and program. There are two types of flowchart, program flowchart and system flowchart, but we will start learning about the symbols of that used in a flowchart. There are 6 symbols for program flowchart. We will focus on program flowchart, not in system flowchart. These symbols, oval, that is used for both start and stop of a problem. After that, this is input symbol and also used for output. When it should be used? When you don't know the value of a number or anything else like that, then you need to take input. After processing, you may find out some result. After calculation, you got the result, and then you need to display the output, the result. Then you also need to use the same symbols. Well, today we will see some example of input output, implementation of all these symbols in real life. Example, these symbols, that is processing means any kind of calculation, summation, addition, subtraction, multiplication, or any other calculation, even keeping some value, assigning some value in a variable, that is also considered as processing. This symbol that will be used for taking decision, you can put some condition here, like is A greater than B, is X less than Y, is M greater than or equal to 0, like this. Whenever you need to ask a question, put some condition, you need to use this decision symbol. This is connection. This used to avoid intersection. Sometimes this used to connect 2 or more output into a single conclusion. And last one is the flow symbol, the flow of flowchart, from where to where going, this problem. Now we will see example of drawing a flowchart. This flowchart will calculate addition or summation of 2 numbers. First we will start the problem, and I have used start symbol. After start, I have taken 2 number as input, A and B. I am considering 2 number. You can consider X, Y, P, Q, or number 1, number 2, anything like that. After taking input, I am calculating their summation. This symbol is used for processing. A and B is adding and kept into sum. Sum means summation. So here assignment operator is used to keep the addition of AB, summation of AB into sum, that is another variable, and here I am displaying the result sum as output, and then stop. We have already seen about the algorithm of the same problem, and you can find the similarities and dissimilarities between algorithm and flowchart for the same problem, for adding 2 numbers, for example. Okay, here is some homework for you, that is theoretical problem. What is flowchart, difference between flowchart and algorithm, and you will write another problem. The problem is